Okay, so today I want to talk about something I've been working on. I've been working on learning Blender instead of Maya. So this is a character, one of my first, or actually my first project in Blender that I've used to try to learn the program. I might cover, if anybody's interested, the difference between Blender and Maya. And this is Blender 2.8, by the way, rendered with Eevee, the real-time renderer. One of the things I really like about the program. The interface is much more user-friendly, more industry standard in 2.8. So if you haven't checked it out, I highly recommend checking it out. But today what I'm going to cover is creating this moon in Blender and sort of reiterate on some of the things that I've done in previous tutorials, particularly decimation or optimization for real-time production. So this is a model of the moon that I've taken from a displacement map, and I'm going to show how to do this and the optimal way to do it in Blender. But you can see this is a low poly, lowish poly moon. I'm going to show how to actually make it lower poly and better quality than what you're seeing here, because if you look at this, the wireframe count, it's like 300,000 polygons. And we can actually do a lot better and get a more realistic look, because what I'm really interested in terms of optimization for real-time or a game engine is not getting, I want all of these craters to show up like they do on the opposite side here where it gets interesting, but I want them to be higher quality. I want lower polygon count though, so how do you get both? So what we're going to do is cover baking a normal map in Blender, and we're also going to talk about how to optimize the UV maps for these spheres so that we don't get this or as much pinching here at the top that you might get off of the normal standard UV or UV mapped sphere in Blender. So let me go ahead and hide this. This is the kind of the high poly version, and here is a much lower poly version using baked UV maps that gives me the same result for like about 1/10 of the poly count. And I'm going to cover how to do that in Blender. So let me hide this. First thing we're going to do is talk about making kind of an optimized sphere. So if we're in Blender in the object mode, we'll hit Add, Mesh, and the normal sphere, you get this UV map sphere. Let me pull it down into position. Let me show in wireframe. So that has this triangulated poles on the sphere. And this, if you look at it in, excuse me, I'm recovering from a cold here. If you look at this in UV editing, let me hit Control All, oops, and then in edit mode, select faces, Control A. I'm not going to cover the Blender interface. There's plenty of tutorials to do that. But what you'll see in the UV map, I've selected all the faces, and this is the UV map that comes with it. As you see these triangulated polygons at the tops or the poles of the UV map. And what's going on is, this is problematic because like when I go to subdivide this to create more detail, this is a large chunk of the topology that's getting triangulated and is going to pinch the closer it gets to this top, which is going to create all kinds of UV artifacts or UV normal map artifacts here. So what we can do to optimize this is if we go into modeling mode again, we're in edit, and I'll select by line, just double click to select this line. What you can do is we'll scale this ring that has quads instead of triangles close to the pole, and then insert additional loops, fix the UV map, and then insert additional loops to kind of fix the way this thing maps. So to scale it, you just start by scaling it smaller. What I like to do is once I get the scale widget going, I'll just set it to like 0.01. We don't want to scale it too small because then it starts to pinch in other ways. So 0.01. I'll hit F to zoom in on that ring. Pull that up to the pole here. So now we have, let's go a little bit bigger than that. It's too small. Something like that for a hole. And what I'll do is I'll delete, go in inside here and select these faces and just delete those faces. So we have a hole in the top of the globe here. We can fix that later, but for the purposes of mapping, this will make it easier for us to pull the detail close to the surface here. We'll do the same thing on the bottom. So go to the edge, double click to select the loop, hit F to center. Scale it smaller, and we'll just set that, and then the first thing I do is 0.01. Let's make it 0.1. Make sure it's the right size. Yeah, it's pretty good. W, and if you zoom in on this and you get clipping, like if I do this where I get in so close that I start to see through the object, you can just bring up the view sidebar here and set your view clipping plane. It's actually, clip start. Set it to something really small like 0.001 so you can zoom in tight on the object. Let me hide the sidebar again. All right, scale that down. And we'll delete those faces. Select by face. All right. So now we have this sphere with these quad loops. Now we need to go into UV mode. Select all again. And you see what we've done is we've deleted those top faces on the UV. So now we have like an unfinished UV map. So if we go here, select by points, or and double click on the line, we'll zoom in on that. So I just double clicked on this line to select them all. Hit W, so that allows us to move them up, and then hit Y to lock it on the Y so we can zoom up to the top. Zoom in and the same thing, W and Y, just to get it right to the edge. You'll see why I'm doing this in a second. And the same thing on the bottom. Double click, W, Y. Y just locks it on the Y so we don't get them out of alignment. Zoom in. W, Y. There we go. All right, so now we've got this UV map where we've gone and extended, and it kind of mirrors what we have here. We have a longer polygon set up here at the top with these squarish polys around the center of the map, or the sphere, but it sort of like comes to a point there. So now what we want to do is we want to insert a new edge loop to get this tighter and fix this. Also to distribute the polygon count in places where it's important to have it distributed. So in other words, all of these vertices right here that pinch at the poles, when we go to subdivide this to create a displacement map for that moon, it's going to be a ton of detail right here in a small portion of the polygon. It's going to be like hundreds of thousands of polys right here with less information around here. So by optimizing this UV mesh so that there are less polys at the pole, that means that the detail will get distributed more in places where it matters. So you'll see what I mean in a second. So what we can do is we can go, if we want to add an extra layer of detail here, we can hit loop cut in edit mode while in UV, and just it'll automatically snap to the center, and I can hold and drag that however I want to apply the polygons, or where I want to apply the loops. So I'm just sitting here thinking which way to apply it. So more here. Yeah, something like, let's go with the halfway. That's what I've done so far. We'll roll to the top and do the same thing. Halfway there. So now if we do select all again, do it by face, you'll see where it inserted those edge loops back into our UV map. Now, one of the last things we have to do is we'll go back to modeling. Up here under the tabs, this is in 2.8. And we'll want to go back and just double click on this edge loop, hit W and F to zoom in on it. Because right now it's just inserted it at a halfway point on a linear line. We can pull that up just to round out the top of the sphere a little bit better, like that. In fact, you may want to pull it up even more. Because when we go to subdivide this, these edges at the top are probably going to like peak like a volcano. Same thing on the bottom. Go to the side and pull it down like that. All right, so now this is what I call a fixed UV sphere. The only thing that I've done to it technically is just fix those peaked triangulated polygons on there, and I'll show you why it works, what it does. One of the things you could do if you have a more powerful machine to help with this, if you don't care about well, your optimization, eventually we're going to decimate this, but if you don't care as much, or if you have a more powerful machine to run this, and I've, like, at one point I had this thing, I was trying to decimate it at 32 million polygons, which is a large number of polygons, and it crashed my, I didn't have enough memory. You can see your memory usage down here on the bottom of Blender. What you could do is you can insert another loop here, closer to the pole. What that's going to do is it'll insert more geometry, but if you go into your UV map, under UV editing, Control All, whoop, we're in object mode. Oops, still in Control A. Insert that edge loop at the top. Let me look at it from the bottom here so I can show you. If you insert an edge loop, say around here, right around the edge, so that you get a ton of you'll get more polygons up here, but they're going to be in places where there's less pixel information on the displacement. It will effectively keep you from getting these like triangulated squeezed vertices along the edge, and you're going to see this in a minute at the pole here. Hopefully I explained that right, but you'll see what I mean when we go to do the next part. So let's go back to modeling. Accidentally shifted my object up. That's fine. Shift it back down to our feet. Okay. Doesn't matter where it's at in placement right now. So for the purposes of this point, I've only had this wireframe turned on in the object tab just to be able to see what we were working on in terms of the lines. I'll leave it on for a second. Next mode that we're going to do. So now that we have this optimized sphere, we can go under modifiers on the object. We will add a multi-resolution modifier, and I'll go ahead and subdivide that just one time so you can see where I'm going and adding geometry now to smooth this thing out. And you'll see what's going on here at the top as I do it. Let's do it again. So you start to get this kind of peak. But you can also see I'm adding a lot more polygons in a smaller area than what I've got around here at the equator of the sphere, which isn't necessarily useful. You could go back, apply this, delete these edges, or dissolve these to try to get it to do less detail up here as a way of sort of getting more detail where it matters. In fact, let's go ahead and just try that. We're going to, just for grins, so let's do that. We're going to go into edit mode. Why talk about it when we can do it, right? So what I want to do is, let me think about this. I'll delete this edge loop right there. Not delete, dissolve by right-clicking and dissolve edges. Get rid of those. Then I'll delete this one too. Dissolve. And yeah, let's go ahead and do another. Dissolve. Thinking about it as I go. And then we'll go down here and do the same. So why am I leaving this ring with a lot more detail here and dissolving the third ring out instead? The reason is like I'm using this ring as a stopgap to close off any kind of pinching at the poles that's going to happen when I go to apply details. These polygons that are really tight here will create a kind of creasing in the normals. One of the things we could do is we could go in and merge points and then create quadded more detail out on the edges. That's just more basically like pinch it here, and that's going to leave a triangle. We don't want that because it's not going to subdivide easily. But if we put a point in the center, which would turn it back into a quad again, and then close that with a loop around here, we'd get more detail around the edge and less, or around the equator and less on the poles. And that's what we're trying to do by deleting these points. And we'll do one more. So you can see where I've got a lot of detail around the outer part of the sphere and then less at the poles. Now, if we go back to object mode, I'm going to add a multi-resolution modifier again, and I'll subdivide again. So you can see and we'll do, how many polygons am I at? I usually look down here at the count. So faces is 75,000, and which isn't much. It's not going to be enough for the subdivision. I'm just adding a couple. There we go. We're going to get up into the millions real quick, but I wanted to go ahead and let's go ahead and shade smooth that. All right, so now going back into the subdivision, or the multi-res, I want to add a new modifier, and this is going to be a displacement modifier. And what this will do is this will take a it's in a modifier stack. One of the things I like about Blender, which kind of comes from 3D Studio Max, I want to take and make a texture. In this case, I have the texture, but I'm going to go ahead and just say, well, let's use the one that I have. I want to show where I got it in a second. So it's going to have this lunar map, an equirectangular lunar map that I've gotten. You're going to want to use local and UV projection. And right now it's set to displace like crazy, and you can see what's going on. We're going to make that like 0.6. not 0.6, 0.06 to get the moon back. So you can see where it's starting to do the displacement. You can see the pinching I was talking about. And it may be by doing that, what I did where I deleted the detail, I just increased the stretching out at the edges. What we can try to do to get better results is to select or set this to sharp instead of smooth, keep corners. And maybe turn off use creases. Nope. I'm going to leave that. So that's what I was trying to do by inserting those loops was deleting those loops was to get this tighter in. I think by deleting those edges, I've basically made it so that it's worse. So we can go back and fix that. All we got to do is go back and delete these two modifiers. They're gone now, and I didn't apply them. So if we go back to edit mode, we can just insert these edge loops back in using our loop cut. So loop, 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 and same thing on the bottom. Now that means that there's going to be more polys there, which is okay, but we'll see how it applies now. So now we go back, add our multi-resolution. Make sure you subdivide at least once. Let's go ahead and apply the displacement modifier. I'm going to show you where I got this texture from so you can follow along. Actually, I just made a new texture. Let's do this one. Set it to sharp under the multi-res, and then we're going to set the texture coordinates to UV instead of local. And we'll go back and set this to 0.06. Alright, so first off, what am I using? What am I applying here? It is a texture which, yeah, this is it. It's this texture. Which if you go online and you look for, do a search for moon displacement. Yeah, let's do map, and this to GitHub is where I got this one from, and it's a good one. So if you go to images, yeah, you'll come across this one right here, and it says Jenga GitHub.io. Go to that, visit, and basically you're going to get to this height maps selection page on his GitHub account. This is the displacement map that we're using for this to basically alter the height of our moon here. And what it's doing is it's taking the grayscale value, in this case a grayscale value from, what I did is I took this 8192 by 4096 bump map, this one. If you zoom in on that, you'll see how detailed it is. And he's got much higher res than this. I think he's got a 90,000K version that gets down to the meter almost, which is too big for, you don't want to use that for this. This is more than enough. In fact, I think I took this and did, I made it 4096 by 2048. The important thing to realize is this texture has this one little tiny black line at the corner. And you're going to want to smooth that out. So you'll save this image, get it, take it into an image editing program and offset, and you'll see the black line, and just smooth out that line. Otherwise you'll get a crease in the map. So what I've done is, so just find that image. What I've done is, you can see when I zoom in, this is, you don't see that black line on the edge, so that when I apply it in Blender, the seam is over here, it's smooth. I did this a couple of times and realized I was getting that edge. It was because of the black line. So now that we have this applied, and we've got this multi-res modifier with the displacement working, what we can do is just keep subdividing. the multi-res. So we are at 176,000 faces. Do another, which is it's gonna quadruple the poly count every time we do this subdivision. So now we're at 570,000 faces. We'll do one more. And you can see where we're starting to get into some really good detail. This image map is like superb. And if I did one more, I'd even start to get like some detail. You can start to see some hard lines. If your machine can handle, we're at 2,143,000 polygons on this subdivision right now. And you can see that the poles are working much better since I went back and fixed the edges. You can see a little bit of streaking there, but that's pretty good. If your machine can handle the poly count, let me go ahead and just I'm going to add subdivide one more time so you can see the detail here. I'm going to tell you this will start to bog down a little bit since I'm recording, but it'll snap and just get really crisp on the edge count here, especially in these areas. But you can see it's thinking about it, but look at the detail that pops out. And might even do better if I went one more, but since I'm at 4 million polygons, actually 8 million polygons here, that's too much for me to record this video and show you guys, but you can see this is a great texture map, and it's got lots and lots of detail. Alright, so what I can do to fix that, I don't want to work on the 8 meg version because it's going to take forever for me to bake this stuff. I'll go down one just by clicking the arrow here to go back to 4, and it takes me back down to 2 million polygons, and I will delete higher to get rid of the higher version. Okay, so from this I've got my high-res model that I can use to bake details. So what I'm going to do is I'm going to go ahead and select my sphere here and call this moon high. Save that. So then we want to go ahead and apply the displacement on the modifiers, this little wrench here. I'm going to say apply. It's going to take a sec, think about it. And I'm going to apply the multi-res as well. Now I could just bake my displacement map with that multi-res modifier using the lows and the highs. The thing is I want to decimate this to get the polygon count really low, because one of the things I'm interested in is keeping this silhouette, even though it's not very high. You can see the edge, how it distorts along the edges. On some of these bigger craters, that actually, I want that sort of edge surface area to show up. And you know, I could bake a normal map from this displacement map. The problem is I'm baking a normal map that doesn't have any detail about the or I could make a normal map from that. I wouldn't bake it. I wouldn't have any detail about the object that I'm working with, its height, and the difference in the displacement. And what we're going to do here is we're going to take this map, this object, make a duplicate, just copy and paste it. It's going to take a sec to think about it, and I'm going to rename this to low res. Okay, so now I have this low res. Well, it's not low res yet. Let me turn off the high res. I want to decimate this. I talked about this in one of my other videos where I'm talking about optimization for real-time display, particularly in A-frame. Turns out Blender has a really nice decimation tool. It does a good job, in some ways better than Maya's. It doesn't give you the control that Maya has, in that you can actually paint maps to form where the decimation occurs, but it does a nice clean job of creating a good decimation map, or a good decimated object. So what you can do is, under modifiers again for this low res is, and the modifiers again is this wrench, go and you want to, under generate, decimate. Now, what you want to do is leave it on collapse. You can try unsubdivide, but the thing that subdivide does is it's just going to take the take it down in quads, squares, and we don't want that for these these edge details on the moon. We want to try to allow it to decimate, and use lower poly count where it's flatter, and use higher poly count where it's not. So we're going to leave it on collapse, and we'll set this to, see, we're at 2,143,000. Let's see what would it take to get it. So like 0.1, we'll take it down to 214,000. 0.05 would take it down to 100. So 0.0, let's try 0.202. So this is going to take a second while it thinks about it, because what it's doing is it's going and calculating the surface of this, looking at the topology based on this displacement, and then everywhere that it's relatively smooth, it's going to decimate it a lot, and then where there's a lot of detail, it's going to try to hang on to that detail by decimating it a little bit less. So I've gone down to 83,000 polygons, and this is what it looks like. It looks kind of bad, like Swiss cheese, right? We're going to fix that. Don't worry about it. And I'm actually going to take it smaller too. So, so one would be 40,000. Let's try doing something impressive where we go down to 0.06. This will be somewhere around 20 or 30,000. So let's talk about, well, I can't pan while it's thinking. I was going to talk about some of the other advantages of Blender. This Eevee renderer is just really superb. Like, you can't, like, one of the things I really like about it is that it's using we'll get into the shader in a minute, but it's using this shader that works for Eevee as well as the biased renderer, or the unbiased renderer that it's using, the normal cycles render for, and the same material will work for both renders. In Maya, you have to use the Stingray PBS or PBR texture, which requires a whole different setup and doesn't cover nearly as many options as this one does. This one will do just about everything, including a really nice looking glass transparency. It comes from the Unreal Engine, I think, shader. But on top of that, it will, like, I mean, this, just look at this glass. Like, for me to be able to render that in real time with transparency and refraction, and you can't, I don't know if you can see, but like there is refraction going on. Like if you look at the edge of her face and her mouth, there's refraction going on in that glass, and I'm getting real-time interaction with it. On top of that, her face actually has subsurface rendering going on in real time. I don't have it set up to show. You have to kind of get it at the light. But anyway, there's subsurface going on in that, and I'm getting refraction maps and reflection with an environment as well. And Maya just would bog down. I mean, not only that, I couldn't do this kind of like heavy, high poly count editing in Maya. And on top of that, I modeled this helmet using Booleans in Blender, which are just superb. And Maya really struggles with Boolean functions. So I was able to like knock out this panel and do all kinds of optimizations on this helmet. So Blender is probably going to be my tool going forward to do these tutorials, but even just to work with, because I'm really liking the way 2.8 works, and the interface is far superior to what it used to be in 2.79, so I highly suggest you check it out. Okay, so we finished our decimation. We're at 25,000 polygons on this moon. Looks like garbage right now, but we can bring it back. Although it's sort of kept the edge detail that I wanted. And I'm going to leave it at that just to prove the point. So 25,000. We'll apply that. So then we're going to have, once we apply it, it will give us our 25,000 poly low-res moon, which looks like Swiss cheese. And we can go and bake the map. We can bake the normal map from our high-res version to this low-res version. And the reason that we wanted to do this decimation from the original is so that we would get a UV map that gives us the displacement from one to the other, whereas just creating a normal map from our first displacement map, like going into Photoshop and trying to render out a normal map from that, would give us some detail. But if we tried to apply that to this, it would look terrible, because what we do by getting this is the difference between this object's poly count, the wireframe, where these polys are, and this higher res version, which you can see sticking out or peeking out through the edges here. We're going to get a difference between those, and that map will then help our low poly version look much better. So let's take the low res, turn off the wireframe again, so you can see where I'm talking about the difference in the details. Alright, so what we need to do to set this up for baking first is, let's turn off the high res so I don't apply that. The low res, we want to go and check out the material. There isn't one, so that's good. We want to make a new material. We'll call this Moon Baked. For that, we need to go into the shading tab. So here's our moon. Here's our material. This is the material I was talking about that works across everything. The principled BSDF works great. Covers everything. It's got subsurface details, metallic, specular. This is based on the Disney principled shader, and like I said, it works across both renderers really well. So what I need to do is I need to add an image texture here. I want to make it a normal map. So we want to add a vector normal map. Put that there and take the color from 1 into the color. It's going to be tangent space. We'll use the UV map for the baking. We want to make sure that it is set to non-color data. And we're going to say a new image. We're going to create a new image for this. We'll call this baked, or moon baked normal. I'm going to leave it at 4096 by 4096 to make sure we get all the detail that we can, and say OK. Okay, that's good. We're going to leave it unconnected, I think, at this point, because really what all it cares about is when we go to select this and bake it, that there is a normal map to bake to, particularly this image. I think if we hook this up, it gives us a circular loop where it bakes back on itself. So I'm not sure of that, but I think that's the error that I got the last time. All right, so go back to model. And let me get out of edit mode, object mode. So now we want to select our high res and our low res last. You'll get, so it looks, we've got the low res selected, it's the target. You could also just select like one of these details and then select the low res on top. So we get that. Okay, so now if we go to our renderer, this render tab here, or if we go to rendering under this tab, this is a normal map I baked before, and we'll get the render tab over here. We want to make sure we're set, our render engine is set to cycles, not Eevee. Eevee's the real-time renderer, cycles the one that we can use to bake. If you have a GPU that's supported, go ahead and use GPU compute so you speed up your render a little bit. And we can go into bake, and what you want to do is select your bake type. What kind of map do you want to bake? We're going to select normal. This is where I was saying if you were doing it from displacement, that multi-res node, you could do bake from multi-res here and select your targets from that. We want to, in this case, bake for tangent space. And then we want to do selected to active, which is why I selected in my objects, I selected the high res and then the low res, and the active. So we're baking from the high res, baking the detail from the high res to the low res. And then make sure that you set your ray distance to something greater than 1. It can be 0.01, whatever. The difference is like if you don't have this set high enough and they don't overlap, or it doesn't cast out enough, you're going to get some issues with the bake map, and you can just come back and like set that to render with a higher ray distance. Once you get all that set, hit bake, and it's going to start baking. I'll come back when the bake is done and show you the results and where to go from here. Alright, so here's the map that got burnt. Or baked, I should say. So what you'll see is that it looks like a normal map normally would, pardon the pun, but there's going to be some details that are going to be sort of hidden away, and that's the difference in the polygons between the two. Anyway, once we have this baked, we need to save it. So go under Image, Save As, call it Moon-Baked Norm. We'll save that. And then you can come back to your shading. So we've got our Moon-Baked Norm applied, and we can just come back and attach that to the normal on our low poly, and go to Modeling. Object mode, and we will turn off our high res so we can see what we've baked. And you can see it looks really good for a 20,000 polygon model, and you get some of the details while maintaining that surface edge. So it sort of makes sense from a object perspective. And just to prove that this is the low poly version, oops, turn on the wireframe. So there's our low poly. You can see where it's done a good job of optimizing everywhere that it's really kind of smooth, and where it adds the details. It'd be nice if it added even more, but we really can't do much with the polygon count that we've added. We've asked it to give us, but for what we've done, the result's good. The normal map, and like I said, if I tried to apply the same, if I tried to do a baked normal map and apply that to this baked model, it'd be problematic. So we do have some issues, it looks like, with our normals. I can't tell what's going on there. My guess is that's a normal map issue. Let's try. In fact, I'm almost certain that it is. So there's probably like some issues with the normals versus the height detail. just trying to see it so I can see what I'm looking at here. So that would be, if the seams here would be about halfway, a little less than halfway in the middle, over down towards the bottom. So let's go back and look at our rendering. Yeah, like somewhere in here. Yep, right there. See these little dots of color. Let me see if I can. I don't know if you can see this, but there's a little yellowish line here, or yellowish patch here, and a yellowish patch here. And basically that, and then there's one right there too, and there's a hard line there. Basically that's where, when I went to go render this, the depth difference of this 0.1 was not enough. So if I just make that like 0.3, got to be careful, because like then you get into these concavity features. So you have to kind of bake this and try different things. But if we set it to like 0.03 and then bake again. Whoops, I got to select my objects, go back to modeling. So moon high res to moon low res, rendering, and bake. Actually glad that happened so that it could show. I wasn't in my model mode. Object mode is what I want to be in. And I need, moon high res, moon low res. There we go. And rendering, bake. So you see where this it came up with a circular dependency, and that's because I had the texture map already connected. I think it'll be okay. We'll see. If not, I can go back and break the connection in the shader. So now you can see where it's going and re-rendering our normal map. So I'll come back when this is done and show you if it fixed. Alright, so here's the render. It looks like it did. Let's go back and check our model. Go to object mode. And I'll hide the high res. Yeah. It's actually much better. So our little dark spots have disappeared on the bake, and that's how you do it. So if you have any questions, just let me know.